So today we're doing section 2.4. This is quadratic equations. So we're going to go over quadratic equations. I think you've seen it before. But in our case, the quadratic equation in standard form is what we're interested in. So this is the quadratic equation in standard form. A times x squared plus b of x plus c equals 0. That's the quadratic equation in standard form, where a, b, and c are real numbers. Um, a is the coefficient of x, and b is the coefficient of x. So those are real numbers, like 10 or 1 or 2 or whatever. And so today we're going to focus on 4 different methods of solving the quadratic equation. We're going to do factoring first. We're going to extract the root. We're going to complete the square, and we're going to do quadratic formula. Um, so to start with, we're going to go over solving by factoring. I think you've seen this, but we'll just go over it really quickly. Let's just start with an example. I think that would be the best thing to do. We have x squared plus 24x minus 81 equals 0. Now, to do the factoring, what we're looking for is something where we can do this. We're looking to do that, to turn that into that. I'm sure you remember that. To do it, if you remember correctly, we had to find something that would, let's see, would allow us to, there's a 1 in front of this, just to let you know, to multiply these two numbers, the 1 and 81, but also add together to make 24. Or not multiply, yeah. So you would be multiplying a times c, but in this instance, which is a here, here, and c here, and c here. But that's just negative 81. So we have negative 81. We need to find all the factors that can add up to 24. So 1 and negative 81, definitely not. You can get 80 or 82. 2, well, 2 don't seem to be working with 81 because it's not even. 3 works, and it is a 27. Now, can we get 24 from that? Yeah, so if we subtract 3 from 27, we get 24. And I think that's where we need to start. So to build this, if you remember correctly, we need to put our parentheses down. Since there is a negative 3 here, we put it here. And a 27, we put it here. And since this is just x squared, we'll just put x in both sections. We'll set it equal to 0 since this is set it equal to 0 here, right there. And then now all we need to do is solve for x for each one of these. So what we do is say, okay, x minus 3 equal to 0, and then x plus 27 equal to 0. And you solve. So this one, we would add 3 to both sides, and this would be x equal to 3. This one would be negative 27 to both sides, and this would be x equal to negative 27. And those are your answers. All right. Um, the next example, let's see if I can just, there we go. Next example has to do with a little bit shorter equation, but nonetheless the same process. So we have x squared plus 3x equals 0. Now, we need to rewrite it in the standard equation form. Remember the ax squared plus bx plus c equals 0. Well, this is kind of really in that form. We're just missing the ending plus c. Um, so it's fine to leave off the coefficient at the end. What we can do here is just pull out x. Since x is here, one of them's there and one of them's here, we'll just take that one and push it right there, and then reduce every one of these by one. And this is equal to 0. Um, so the way we solve this is this outer x, we can just say x equal to 0. And this inner x, we say x plus 3 equal to 0. And this is x equals negative 3. And these are your answers. Okay. Now, we're going to be doing extracting the root. So to okay, if we have a quadratic equation where we want to extract the root, we have something um like we had before. And this right here is called a pure quadratic equation, something like that. And we would use extract the root to solve this, and this is why, and I'll show you. So we want to move, let's solve this for x, and so we'll move c to this side by doing minus c. So ax squared equals minus c. And then we want to move a out, so we divide a out. So we have x squared equal to negative c over a. That is a c. Now there's several ways to solve this, but we see we have this this power of 2 here. The way to solve that is to do square root of both sides. So this would be x equal to square root of negative c over a. It may not look clean or nice, but it does help when you're trying to solve these equations. And so with that, we'll just jump right in. I have a 3x squared minus 4 equals 71. So we want to solve for x first thing off. So let's do this 4 first. We plus the 4. And that gives us 3x squared equals 71 plus 4, right? Which is just 75. And now, because this is multiplication, we need to remove the 3. And then we have x squared um, equals, now what's 75 divided by 3? That's right. It's easy. X equals 25. No, wait, it's not x. It's x squared. Now, how do we solve this? We do the square root of both sides. So this would be just x, and the square root of 25 is just 5, but we write it as plus or minus 5. Now you see where those inequalities came into handy, huh? Now, this is the answer for this. Um, but they do want you to check check your answers. But you have to check your answers on +5 and -5. So you would have to do it like +5 squared minus 4 equals 71. And then you'd have to do 3 minus 5 squared minus 4 equals 71. And I mean, we could do these if you want to. We'll start this one. So this would be 5 squared is 25, right? And 25 times 3 is 75. So this would be 75 minus 4 equals 71. And of course, this would be 71 equals 71. And that checks out. But, well, the negative check out. So if you do -5 squared, what do you think you're left with? What's a negative times a negative? Yeah, it's a positive. So we would actually be left with 25. And this is -4 equals 71. And then this solves just like this solves. So you would be 71 equals 71 eventually. All right. So our next example um, contains a perfect square, or something we could do with a perfect square is use extracting the root to solve it. So let's look at it. We have a w plus 2, and that is squared, and it also equals 9. Well, how do we solve this? Well, we have a squared on this side and a 9 on this side. Let's just square root both sides. So you're left with w plus 2 equals plus or minus 3. Now, we should solve this for w, right? And that would give us our answers. But we solve it saying, okay, we need to solve w plus 2 equals +3, and w plus 2 equals -3. And if you solve these, you get w equals what? Just 1. And then this one is w equals -5. And these are your two answers. You can check your work. Just plug it into the original equation and do the math. And we could do that real quick. So for 1, we have 1, work out 1 plus 2 squared equals 9. And that's 3 squared equals 9. And then that's 9 equals 9. That worked out. And then the other one is -5. So we got -5 plus 2 squared equals 9. And -5 plus 2 is -3. But 3 squared, because negative times a negative is positive, is 9. So we get 9 equals 9. All right. We're going to do completing the square. So completing the square is a method that you can use on all quadratic equations. Um, and it involves some steps that we've done before, but we're combining those steps. So in this case, we have x squared plus 8x. equals 4. Ooh, excuse me. So it says the first step, move the constant to the right of this equation. Well, it's already done. Constant is right here. Divide both sides by a. Well, a, if you looked at the equation here, this is the equation. And this fits that. So a would be here. Divide both sides by a, you'd just be doing about 1, and it's already 1, so 1 wouldn't change anything, so we're not doing that. Now we square half the linear coefficient. Linear coefficient is b, and add the square to both sides. All right, so this is 8. See, it's b, which is 8 on our side. Half of it, you divide it by 2, obviously, and you get 4. So the equation would look like this. Basically, you'd be saying 8 over 2 squared, and whatever that is, right? So 8 over 2 is 4, and squared, and that is 16. So 16 we have to add to both sides. So this would change to x squared plus 8x plus 16 equals 4 plus 16, which is really just for the sake of space. This is just 20 because it's 4 plus 16. All right. Now we factor out our polynomial. And what we're trying to do is write it as something like this. Now, I can tell you this is a perfect square, so it will be easy to factor out. But I don't have to do that. We'll write it out anyway. So we take this term and this term, multiply it. That's just 16, because 16 times 1 is, well, 16. We're trying to find factors that add to 8 or subtract that make up 8. So what about 2? 2 goes into 16. How many times? Oh, okay, it's 8. I don't think that'll work too good, will it? I don't think so. So our next number is 3, but I don't think 3 will work. Let's see, what's our next number? What about 4? You think 4 will work? Well, if you put 4 into 16, you get 4 out. And 4 plus 4 is what? 8. That's our numbers. So we get x plus 4 and x plus 4, which you can rewrite as just plain old x plus 4 squared equals 20. Now, does this look familiar? Maybe it's something we just did. We can extract the square root. Let's do that. Square root both sides. It kills that square, so we're left with x plus 4 equals to the square root of 20. And the square root of 20 we'll have to talk about. So the square root of 20 will give you a decimal type number. But there's a way to make this into a proper or improper square root. So I think I think you've done this before. Square root of 20 is acceptable, but if you want to talk about really simplifying it, we could pull out a number out of here. Let's say we pull out 2. We can start with 2. If you pulled out 2 from 20, you're left with 10, right? So, but I don't think that would work very well. And something we forgot is this needs to be plus or minus, um, because we did the square root of both sides. We did the extracting the square root. So to simplify this, we need factors. So factors of 20 are obviously 1 and 20, 2 and 10, but none of these are perfect square roots. 4 and 5, actually, that will work because 4 is a perfect square root. So we can pull 4 out, meaning that if we did square root of 4, or right, here we go. I'll just show you. Plus or minus square root of 4 times 5. But 4, square root of 4 is just 2. So this can be rewritten as 2 square root of 5. That's a simplification of the 20 right there. X plus 4 equals. Okay, so we need to solve this to get x by itself. And I think I've run myself out of space for some reason. Um, okay, here we go. X, okay, so x plus 4, we need to move the negative 4 over, or the 4 over, and that will be rewritten as x equals minus 4 plus or minus 2 to the square root of 5. Now, how do we solve this? Well, we have x on one side, but we need to do both the positive and the negative for this. So this would be x, and we're branching this out. X equals negative 4 minus 2 square root of 5. And then this one, that would be x equals negative 4 plus 2 square root of 5. And we'd solve for both of those. Now, if you just use your calculator and you do the math, so you would say square root of 5 and then times 2 and then minus 4. You should come up with the right answers, which are negative 8.47. And this one is just 0.47. Okay. Moving on. We're gonna do another example. So we're gonna do this one by completing the square. And this one, we have a little bit more to do, but it's the same type of equation. So r squared plus 12r minus 2 equals 7. So this time we have a coefficient. We have this coefficient right here. So we need to move it to the right-hand side of the equation. And to do that, we just plus 2 both sides. We end up with r squared plus 12r equals 9. Now, we need to divide both sides by a. Well, a is right here is just 1. and there's nothing to do. The next step is square half of the linear coefficient, which is this 12. So half of 12 is 6. So we're basically doing 12 over 2 squared, and that equals 6 squared, and that equals 36. So because 6 times 6 is 36. And we're going to add that to both sides. So we have r squared plus 12r plus 36 equals 9 plus 36. What's 9 plus 36? Do we know? Can you do that in your head real quick? It is 45. All right. We need to factor this polynomial. And because we did this, we know it's going to be a perfect square. And because we know it's going to be a perfect square, we can take 36 and factor it with two numbers that are going to be exactly the same. Or anything that adds up to 12, which, if you think about it, we found this by doing sixes. So this would be 6 times 6, and 6 plus 6 is 12 also, so it works. So we would just rewrite this as x, x plus 6, or r. It's actually r. We're doing r's. X plus 6 squared equals 45. Now we're in the format we can use our square roots. So this will be r plus 6 equal to the square root of 45. Well, okay. 45 can be rewritten into factors. So we have 5 and 9. 5 times 9 is 45. Well, 9 can be rewritten. It's a perfect, it's a square root that gives you a perfect number. So let's do that. So the square root of 9 is 3. So square root of 9 equals 3. And that's what we're going to pull out. So we have plus minus 3 square root of 5. All right. Solve for r. This would be r equals negative 6 plus or minus 3 square root of 5. Now you could have left it square root of 45. The calculator does it either way. It's fine. I can show you the difference. But you would need to solve this using branched out methods. So you would be branching out r equals negative 6 plus, let's just do square root of 45. And then r equals, okay, negative 6 minus square root of 45. And if you did those in your calculator correctly, and you would get 12.71, and then just 0.71 here. And that's your answers. All right. I have another example here. And this is 3y squared. Y, but I don't know, maybe 12y. And plus y. I mean, 8y. Too many y plus. All right, equals 5. All right. we need to, first thing we need to do is move the constant to the right. Well, we just do a -8 on both sides, and that gives us 3y squared minus 12y equals -3. Now, we need to divide both sides by this coefficient. So divide this by 3, divide this by 3, and this gives us, the 3's cancel out. The 3 and the 12 make a 4, so we're looking at y squared minus 4y equals -1. All right. We had to divide. This is dividing by that leading coefficient. We hadn't had to do that yet, and now we're doing it. So that's why that extra step is there. Now we square half the linear coefficient. What is this guy? We square half of him, so it looks like this. 4 over 2 squared, which 4 over 2 is just 2 squared, which actually equals just 4. Really? So here we go. Y squared minus 4y plus 4 equals, now we're going to add 4 to both sides. So this is here, so that's going to give us 3. This we can rewrite as, well, okay, we'll go through the steps. We know it needs to be this one times this one. That's 4. It needs to add up to 4. So we have the factors of 4, which is 2 and 2. 2 plus 2 is actually 4. So we can rewrite this as y plus 2 squared equals 3. Now we can solve that by using our handy dandy square roots. And that gives us y plus 2 equal to the square root of 3. And plus or minus, plus or minus. And now y equals -2, because I'm moving this 2 over, plus or minus square root of 3. And you would solve this by saying y equals -2 plus square root of 3, and y equals -2 minus the square root of 3. And you can do those on your handy dandy little calculator thingies. And I mean, you're going to get 0.27 something, 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 something. And here you'll get something like, wait, what have I done? Was this y plus 2 or y minus 2? Oh, negative signs will kill you. They really do. This is supposed to be y minus 2. So why did I make it plus? Anybody know? Well, that's okay. Outcome's the same. Sort of. Outcome is a little bit different, but okay. Y minus 2, we did add 2, so that's a plus 2, plus 2, plus 2. This number's the same, and then we get 3.73 for this one. And you can do those on your calculator, and I can help you see how to do those square roots, but I think you do those. All right. Now, we're going to add something else to it. We're going to actually add a different formula. This form is fairly important, but we're going to go over it briefly in this chapter, and I think we're going to go do a little bit more with it in another chapter. So we're going to start using the quadratic formula. I don't think I've already told you that, but let's look at where the quadratic formula came from. So we looked at this before. Oh, excuse me. Bx plus c equals 0. This is standard form, a quadratic equation. So we want to come up with the quadratic formula by solving this for x. This is how we came to create the quadratic formula. So move the constant to the right. So ax squared plus bx equals minus c, because we subtracted c out on both sides. And then we want to divide by the leading coefficient. It's the same stuff we've been doing. Excuse me. Divide by the leading coefficient. All right, so let's do it. A. This is ax squared plus bx over a equals negative c over a. Okay. Now, we need to square half the linear coefficient and add it to both sides. So the linear coefficient we said was, this is not a 6, this is a b. We said was this 6 right here. I mean the b. Oh goodness. Okay. Right. So we said it was b. And add it to both sides. So um hmm. Okay. So because this is a what do you call it? Division. It's division. It has division right here. It's a little more complicated, but not too bad. So what we're going to do is usually we would take this b over 2 and we would square it. And that would give us our answer. But since there's an a here, this needs to be 2a because it's essentially bx over a. So this is b over 2a squared. And that's what we need to add to both sides. So x squared plus bx over a, and add b to a squared. And do the same thing to this side. B squared over 2a squared. No, wait. Why am I writing it this way? Because I can. Actually, it wouldn't be 2a squared. It would be, if we took the square out, this would be 4a squared. Because you're taking the 2 and you're basically squaring both things. But that wouldn't be a squared then anymore, would it? No, I guess it would. Because it would be a squared because a was not squared here. Yeah. Okay. Excuse me. Mm, mm, mm. So we'll take this information and convert it to now. So we've added, oh, we actually have it. Minus c over a. There we go. We've added that to both sides. Now the next step is to factor the left side, simplify the right side. So we need to factor this side. Oh boy. Factoring. I'm just going to tell you, we'll just rewrite it. It's going to factor out to be x plus b over 2a and squared. And then that's going to be equal to b squared minus 4ac over 4a squared. Squared. There we go. Okay. Now we need to do the square root trick, both sides. And this ends up being just x plus b over 2a. Oh, I don't have it right. And this is obviously the square root of that. That's what I don't want to rewrite it. Well, I guess I have to. It's plus or minus the square root of b squared minus 4ac over 4a squared. Now, we need to solve for x. So we can just move this whole thing by subtracting it. So this would be x equals negative b over 2a plus or minus square root of b squared minus 4ac over 4a squared. Now, we can further simplify this. And hopefully, I got some space to put that. We can further simplify this here to be basically what the quadratic equation is today. So x equals negative b. You see the negative b there, plus or minus the square root of b squared minus 4ac over. Now we've took the square off of the 4a squared, so it should be just 2a. And that is the quadratic formula. That's how we came to it. Now, you've been doing all the work to come up with this quadratic formula. You've done the square root. What was the name? Square root. Extract the roots. Good grief. You didn't extract the roots. You've been solving the equations like this by moving the equation over. So you know how we got to this. Now, we need to use it. To use this, we write the equation that we have in standard form, identify the values a, b, and c, and just substitute the values in this equation, and then solve. That will help you solve a quadratic equation. Well, now the fun stuff. Let me just do this, and given that 2x squared plus 7x plus 5 is equal to 0. Excuse me. This is in standard form. See, it's got the square of the x, the coefficient equals 0. Standard form. We know that because of the ax squared plus bx plus c equals 0, that a equals 2, b equals 7, and c equals 5. Now, we take our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a Excuse me, and plug in our numbers. Well, okay, let's plug in our numbers here. It should be fun. B, okay, so this is -7 plus or minus the square root of B, which is just 7. This is negative because this B is negative. 7 squared minus 4 times A times C, which is 5. Okay. All over 2A, which is 2. Now I could put these in parentheses. I guess that might help. But the logic's the same. Well, let's solve it. Now, first of all, let's just solve what's on top. What is 7 squared? Well, it's 49. So let me see how I write this. -7 plus or minus the square root of 49 minus 4 times 2 times 5. 4 times 2 times 5? Well, what's 2 times 5? Is it 10? Okay. And then 10 times 4? It's 40. So here we go, 40. All right, all over this 2 times 2, which is 4. Solving further, 49 minus 40 is, well, -9, right? No, it's actually just 9. So this will turn into -7 plus or minus the square root of 9 over 4. Okay, so we know what the square root of 9 is. It's just 3. So do we need to go ahead and write this as broke out because of this plus minus? We write it as -7 plus 9. I'm sorry, plus 3 because that's the square root of 9 over 4. And we write it as -7 minus 3 over 4. We can solve this. And these are x equals, just so I'm not confused. All this is x equals. Yeah, okay. So let's solve this. -7 plus 3. Now that should be just -4. All right, so x equals -4 over 4, which is actually just -1. And this one is -7 minus 3. So I believe you would be x equals -10 over 4. We can simplify that to be -2.5. All right. These are answers. So x equals -1 and x equals -2.5. That's our answers. We use the quadratic formula. Huh. Well, let's do another one. Oh, goodness. This one wants to throw you a curveball. It wants to make it look difficult without it being difficult. So let's go through it. 1/3. This says k. I'm going to use x. X squared plus 8/6 x plus 2/3 equals 0. Perfectly legitimate. We can use this. Um, there is something we can do, however. Excuse me. We can find a common factor that would help us get rid of all these fractions. Since I know that, excuse me, since I know that 3 can go into 6, um, I think we should just use 6. That's the least common denominator is 6. If you need help doing that part, just come see me. But the we did least common denominator just not too long ago. So we'll just use 6 as a least common denominator. And the easy way to do this, because it's uh, this way, is just write it like this. Yeah, I think this is right. This feels right. And equals 0 times 6. Because what you do to one side, you got to do the other side. Which is interesting because 0 times anything is just 0. So, well, this will turn into, if we do the multiplication, distribute within each one like this is basically saying 6 over 1 times 1/3. And if you do that math, 6 over 1 times 1/3, you get 6/3, which is just 2. This is why we're doing this. So we get 2x squared plus, and this is 8/6. So we're doing 6 over 1 times, times 8/6, which if you cross it out, just turns out to be 8. So we could just put, oh, good grief. My drawing is getting worse. 8x plus 2/3 and 6 over 1 over 2/3. 3 will go into this 2 times, so this should be just 4. So we will write down the 4 here equals just 0. So look, we made it easier to read. And that's what you should try to do. Find the LCD, do the math, get rid of the fractions. Okay. Oh, I got to make myself more space because we're going to need it. There. Okay. Now we identify A, which A equals 2, B equals 8, and C equals 4. I wonder if my mouse is going dead. It's not acting right. All right. Let's use the quadratic formula. Plug in these variables. I'm going to plug in my mouse. All right. Plugged in my mouse. Let's say that x equals, well, this is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over the little 2a. Let's plug in our numbers. X equals negative b, which we said b was 8, so negative 8 plus or minus the square root of b squared, so 8 squared minus 4a, a is 2, c is 4, all over 2 times a is 2. All right, let's go ahead and, you know what, let me do this. X equals, because I know that negative 8 ain't moving right now. Square root of, let's see, 4 times 4 is 16. 16 times 2 is 32. And then we got 8 squared to deal with. So This is 32 on this side. And then 8 squared, which is what, 64. Put that here. So 64 minus 32 is just, well, 32. All right, so we know 32 goes under here, and 4 will go here because it's 2 times 2. Is 32 well, is it something that'll come out of a square root? No, it's not. So how do we solve this? Or what do we do with it once we find this? Now, finding the factors of 32 and breaking out that square root is a way to do it. And it is a good way to do it. And we do need to keep doing it that way because it will help us. We could also solve it without doing that. It's not, I mean, okay, let me just show you. The book says that we should break this out, but in reality, well, we don't have to. We could just say that, okay, well, this is as far as we can go with this. Let's just rewrite this as x equals -8 plus the square root of 32 over 4. And this one is x equal 8 plus the square root of 32 over 4. And just, I mean, since we have handy dandy calculators, we could do 32 square root plus -8, right? Well, okay. I'll say 8 and then negative. And then say plus the 32 square root. Okay. And then divide that by 4. And that looks like 0.58, something like that. So this would be x equals -0.5. If you round, it's 5.9. And the same thing with this one. You would get x equals about -3.41. Not to be confused with 314. All right. So we solved that one by killing the fractions. Okay. The last section of the book talks about discriminant. Oh boy. Inat. Okay, discriminant. Excuse me. That is talking about when we have the quadratic formula and we have the b squared minus 4ac all over little 2a. This is the discriminant. Now, if that discriminant equals 0, then our solution is rational. Rational? Oh boy. Okay. And we can have real solutions. So there's one real solution. If this equals a perfect square, let's see, like, okay, so 4 is a perfect square, meaning you could do this to it and you'll get a solid number 2 on it. You'll get a 2. If it's a perfect square, then it is also rational. and there are two unequal solutions. And there's one solution. All right. If it is not a perfect square, like the number 29, if you did this to it, you would get some dot something something something. This is called irrational. Irrational. There's two unequal solutions too, it says. Which don't make sense to me. All right. So given that, if I told you that the b squared minus 4ac was going to equal 12, what would you say? Well, it's not 0. Oh, also, if that solution is negative, I don't know why, a negative value, so that solution is not real. But they're going to talk about that later in the book, so we didn't talk about it right now. But anyway, keep going. This is a 12. It's not 0. It's greater than 0. Is it a perfect square? So saying if you did that to it, what would you get? So you would definitely would not get a real solid number, like a real integer. So this has to be irrational. Okay. And let's say it was going to equal 81. Now, using your handy dandy little calculator thingy, if you put 81 in here, it comes out to be 9. So if you do this, it equals 9. It is a perfect square. So it is a rational solution. Irrational, rational. If you have one that equals 0, it's automatically rational. Done. And that's what I need to know about those. Okay. You had a lot of data in this one. You built up to certain levels of solving. So in the book, it breaks up your homework into sections, the sections we learned today. So you have solve by factoring, you have solve by extracting the root, you have solve by completing the square, and then you have solve using the quadratic formula, is what we did. And then it has identify the number of solutions. So for 2.4, I want you to do 1 through, oh boy, well, 40. That should be enough. 1 through 40, blue. Blue. Okay, that's blue. 1 through 40, blue. And good luck.